Hi, welcome back to Moose and Chemistry. This is Chemical Equilibrium and Rice/Ice Problems Lesson number 2. Find the KEQ for the chemical equation 2AB plus C2D yields A2D plus 2CB. Alright? Important to remember that this is a solid and this is a solid, because that's going to play into what we do with our rice table. So let's go ahead and write our reactants in. So we say this is 2AB, and we're going to call this a gas. This is C2D, that's a solid. This is A2D, that's a gas. And this is 2CB. Alright, now, first things first. The solids, can't use it. So we're going to put X's in them. We're basically throwing them out. Okay, it says that AB and AD2 are both 30 on our initial. So 30M, 30M. Okay? The concentration of equilibrium for this is 0.20. So to get to from a 0.30 to a 0.20, we have to have a minus 0.10. Okay? So now, when we look at this, look at change. Okay? So the change is, since they're both the same, this change is going to be 0.20. So at equilibrium, this is going to equal 0.50. Okay, now let's do the KEQ. So the KEQ of this particular product, remember it's products of reactants. So here's our reactant, this is a reactant, this is a product, this is a product. But we can't use this one because it's a solid, and we can't use this one because it's also a solid. So this is going to be our product over our reactant, which is going to be 0.20 divided by 0.50. So our KEQ is equal to 0.80. Pretty darn snarly. Alright, let's look at the next problem, okay guys? So the next problem deals with if 0.50 mole of N2 is in a 2-liter container to make the products NO and NO2, find the KEQ for each substance, and the KEQ is 1.2 times 10 negative fifth. Alright, so first of all, let's go ahead and write our equation in for our reactant. So this is 2NO2, and it's a gas. And this NO here, guys, is going to be a gas. And this oxygen is going to be a gas. So this is going to be 2NO gas plus O2 gas. Alright, now, normally we would write in 0.5 for our initial concentration, but look, we have a 2-liter container. So we have to change the molarity, so it would be 0.50 divided by 2.0. So our molarity is going to be 0.250. So our initial molarity is going to be 0.250. There we go. And then our initial concentrations for our products, since they haven't formed yet, are going to be 0 and 0. So we have a 2 here, so we're going to subtract 2x, more or less. And we have a 2 here, so we're going to add 2x here. And we only have a 1 here, so we're just going to put an x here. and that's going to be an addition of an x. Okay? So equilibrium would be 0.250 minus 2x, 2x, and x. Now we have to find we have to find our product total. So let's see here, we get KEQ equals products, and we'll call that P, over reactants, call that R, right? Just going to shortcut it a bit. And we know our KEQ, so it's going to be 1.2 times 10 to the negative fifth. It tells us this right here, right? That's going to equal, let's see here, it's going to equal, we have 2x, right? So that's going to give me, a moment. So our product's going to give me 2x squared times x. Why? Because this 2 gives us this 2 right here. Awesome. Divided by, of course, our other number, which is going to give me, please. 0.250 minus 2x squared. Okay. And when we do this, this is going to give me 1.2x times 10 to the negative fifth equals 4x cubed over 0.0625. Now guys, what about this x here? Well, if the value is very, very small, you can just drop it. I know that seems really kind of messy mathematically and it drives people crazy, but yeah, you can do it. 4x cubed equals 7.5 times 10 to the negative 7. So you divide this by 4 and take the cube root of it, and that's going to give me approximately 5.72 times 10 to the negative 3. So what we're going to do is we have our x value, right? And we're going to take our x value and put it back into our problem above. So watch what we do here. So our NO, so if we want to find our NO to find the change, right? So we take NO2 is going to be 0.250 minus 2 times our value, which is going to be 5.72 times 10 to the negative 3. And that's going to give me a molarity of 0.24 m. I know, this is really interesting stuff. So NO is going to give me 2 times, it's like 2x right there, 2 times 5.72 times 10 to the negative 3. So our NO value is going to equal 0.011 molarity. And last but not least, our O2 value is going to equal 0.00572 which is this number right here. Okay? And that's it, guys, and that'll be the molarity there, because it's just x. See, you just put that value in for x, and you get that number. Or you could call it 5.72 times 10 to the negative 3. Listen, guys, that's it. You be snarly, and we'll see you back here at Musin Chemistry.